This is the Primary Math 4 class recording for week 3, getting us ready as we prepare for that next set of assignments for the students. We're working in all 3 books this week. The workbook, exercises 11 to 15, the intensive practice, page 18 to 25, stopping at the top of that page, not working on to the word problems, those will be next time, and then page 19 through 26 in the word problem book. So let's start by talking about the workbook. In the exercises. On exercise 11 and 12, it's just practicing long division and also multiplication. This is not mental math practice necessarily, but you're not going to solve the problems with mental math, but you are going to teach your student just to make a quick estimate, which is often done with mental math. And that estimate helps you know, am I on the right track for my problem? Am I getting that correct? And so the mental discipline of looking at a problem, like for example, I'm on exercise 11, number 1C. The problem is 5,987 times 8. It guides you to estimate by rounding this to 6,000 times 8. If you have 8 6,000s, then you're going to have 48,000. And then if you actually do the multiplication, and this really is just simply doing the long multiplication and coming up with 47,896, the fact that these numbers are similar, close together, tells you got the right kind of an answer. You could still get a wrong answer. You could still have gotten, 47,696, but you're not totally off. You've got the right area, the right size of a number, all that kind of stuff. The thing that always frustrates me about the rounding of all of this is, how do you know where to round something? And so on exercise 11, it's always to the nearest thousand. On exercise 12, when you're doing division, let's look, for example, at 1D. We have 6,480 divided by 9. When you round that in order to divide, you need to think about the fact that 9 times 6, no, I'm sorry, I want to do 7. 9 times 7 is 63. 9 times 8 is 72. Considering 63 and 72, I'm closest to 63. So when I round that, I'm going to round it to 6,300 divided by 9, because that's going to give me 700. And then when I actually do the division, now this is the way we always do long division, and I think it's even how Singapore math teaches to do long division. If your student struggles with that, you might just show them this. If I'm trying to divide by 9, I can think in terms of the next multiple of 9 is 6,300, and I have 180 left over. If I divide this by 9, I have 700. If I divide this by 9, I have 20. The answer is 720. I think that's an interesting way to divide, especially if your student struggles with long division. Breaking it down, all we're doing is saying that 6,480 is the same thing as 6,300 and 180. Each of those are divisible by 9 very simply, and we go on from there. I will tell you, I was quite confused until my daughter explained to me the puzzle on number 2, exercise 12, number 2. The bottom of the page has that puzzle. What you're actually coloring in are the paving stones, not the boundaries. Maybe I should just call the boundaries. The sidewalk you're walking on is left white. You're coloring in the boundaries. Think of them as the bushes, right? And the pavement is left white. So when I was working it, I couldn't figure out what in the world. I couldn't make my path connect. It didn't connect, and it was because I wasn't supposed to do that. So I always have my children do the top part all the way and then color in the bottom, just so they can't cheat and get the answers the easy way. I want them to actually find it. Now it's harder to do it on this one, to cheat and do it the easy way, because it's not an easy way. You have to actually do the problem. So that's how that goes. I did make a note on the solutions recordings. All of the word problems that are in the intensive practice book, and in the challenging word problems book are on solutions recordings. And they're posted online on the Singapore Math Live website under the Primary 5 page. The word problems that are in the workbook are not on a recording. Certainly if you ever have trouble with them, I'd be happy to talk to you about them. They are generally speaking pretty easy word problems. I don't think they give us any trouble, and I didn't mark any to do together. Let me look at those again real quick. I think on those I would just suggest that you always do a picture. You encourage your students to do a picture. It just helps us to make it visual. So for example, on exercise 13, number 2, the number of meat buns that a baker makes is 4 times the number of curry buns. So generally speaking, we just do something like this. And we know that he made 4,864 meat buns, and we want to know, and we want to know how many more meat buns he made than curry buns. Always be careful when you're doing Singapore math that you know what the question is. The question is, how many more is this? And so by the time you see it written, probably you can recognize that we're going to take 4,864, we're going to divide it by 4, and that will give us how much one block is. And then I'm going to take that number and multiply it by 3, because that's how much more we have. Now again, you can have your student do the long division, what I would call the normal way. Okay, I might just show you a different way. I think of 4,864 as 4,864. You could think of 864 as 864. And if you're dividing by 4, 4,000 divided by 4 is 1,000. 800 divided by 4 is 200. 64 divided by 4, okay, I happen to know that one, maybe your child doesn't. Maybe you take that down to 40 and 24. So that would give you 10 and 6. 1,216 is 1 square. And so if I triple that, I have 3,648. Again, if you can go left to right, do it mentally, great. That's a pretty easy one to do it with. But there are 3,648 more meat than curry buns. So drawing a picture is helpful. Division can be done this way, I think, very simply, especially if you're struggling with division the long way, and many students do. Exercises 14 and 15 are all about multiplication practice. And the one thing that we want to do on these is make sure that we get very comfortable with zeros. When they figure it out, it's nice when they can kind of discover it, but if they can discover, and if you need to poke them and prod them and teach them a little bit, that's okay too, discover how the zeros work. Looks odd. Discover the zeros, the fact that the zeros kind of carry, in a sense, in multiplication. So for example, if I'm doing 670 times 80, it's actually going to be the same thing as 67 times 8, and I can just stick 2 zeros on the top of it. 1 0 comes from that 0, the other 0 comes from the other one. We need to realize that this is the same thing as 67 times 8 times 100. We could call it 67 times 10 plus 8 times 10. I'm sorry, times. It's all times. Not a plus in there. So if I regroup that, I have 67 times 8 times 100. So when we do this, and again, as a student or as a teacher, I would encourage you to think of this as being 48 tens and 56. When you do that mentally, we end up with 536. And I have the 2 zeros, 53,600. So you can carry zeros down, bring them down, because you're multiplying by 100, which just moves your decimals around and adds zeros on the back of it. Exercise 15 does that a lot right there in the beginning, a couple of pages, just to make sure you have lots of practice with it. And pretty much the workbook should not, I don't think, give you any trouble this week. Moving on to the intensive practice book, where you're working pages 18 to 25. This is a bit long in the work. It's not awful, but there's quite a bit of work to it. And I would say that, it's just getting through the practice of multiplying and dividing and making sure that you do it as fluently as possible. Notice on page 18, for example, number 1 is long multiplication. And then number 2 has the same problems, and you're going to estimate the answers. Now, anytime the Singapore math stuff gives us an estimate, sometimes they just seem to pull out different estimation rules out of the hat. Like sometimes they do it to hundreds, sometimes they do it to thousands. I personally can't find any definite rhyme or reason as to when they do one way or the other. So I would suggest this. On an estimate, you could check the back of the book and know how they do it, to know how to help your child get the same answers. But the other thing is, if your child has a reasonable estimate and they give you a good answer, it was good enough. If you want to tell them to estimate, like on number 2, that goes to the nearest 100. And on 4, let me check something on that real quick. Yeah, it is what I thought. On yes, we're doing the division on the 4, okay. And so on number 4, when you're doing the division and you're estimating division, it's as much of a multiplication problem as it is a division problem. I need to look at my 2200s and think about the closest multiple of 4. Of course, 4 times 5 is 20. 4 times 6 is 24. So 22 is right in the middle. The 7 tells me I'm going to go up to the 2400 divided by 4 and get 600 for an answer. This was actually number 4C. Each of those is the same idea. You want to go to the closest, not the closest 100 or the closest 10. When you're doing multiplication, you round to the nearest 100 or 10 or whatever, 1,000, whatever you're doing. When you're doing division, you have to round to the nearest multiple, okay, of the number. So that's one extra little thing to do. On to the next page, dividing by 10 is very important. When you divide by 10, for example, part D, when you have 1,240 divided by 10, what your student will realize pretty quickly, if they haven't already, is dividing by 10 every time simply moves your decimal one place. And that is always true, and it's a good thing to get to the point of being quick with that. What about in part G, where they don't go in evenly? Now, this is what makes me think maybe the book is expecting us to actually do the long division problem, because when it gives us this answer, it doesn't give it as a decimal, it gives it as a remainder. When you're dividing by 10, it's going to go 462 times this extra number that's left over is going to be my remainder. So the answer is 462, remainder 9. Now, if you want to demonstrate that, of course, again, I've gotten to where I do division this way more than the traditional way when I can. And if I'm dividing by 10, there are 400 tens in 4,000. There are 60 tens in 600. There are 2 tens there, and that is not a 10. So 462, remainder 9, is the way they do the remainders on number 5. Number 6, again, I think they do a great job of just bringing us step by step by step down into the next kind of problem. So they give an example up at the top of that. Again, I'm on page 20. We're looking at number 6. So when you are multiplying, for example, on H, 832 times 90, you can think of it as 832 times 9 times 10. And then you can do this first and then multiply it by 10. How are you going to do that? Well, you can write it all out. You can do it mentally. You could say that's 72,000, 9 times 800. 9 times 30 is 270. 9 times 2 is 18. I'm sorry. 9 times 30 is 2,700. Nope, hold on. That's my other zeros I have off. Let me fix myself. There we go. 9, you have to stop and think. 9 times 8 is 72 with 2 zeros. That's what I needed to have. So this multiplication, 7,488 times 10, 74,880 becomes our final answer. Easier done than said, I would say. The point with this is, is it still mental math if you make notes to yourself? I would say yes, because part of that is as you begin to make the notes, you begin to be able to keep more and more in your head, and in making the notes is kind of the baby step towards doing it completely mentally. All right, Singapore math taught me a wonderful thing in multiplying 2-digit numbers. I want to make sure that you know how to do this. I believe I saw it in the Primary 3 book. So if you didn't go through Primary 3, you might not see this, and that would be why. What they teach is this lovely thing. Step 1, 9 times 6 is 54. And so the 5 is something you basically carry, and the 4 gets written down here. So 54 goes like that. Step 2 is to multiply these two numbers. So 2 times 9 and add 4 times 6 and then add that 5 that you got from the top part. 18 and 24 and 5. Can you see that if I gave 2 of these away over here, I'd have a 20. That makes 44. And there's 3 left still over here, so that's 45. So of the 45, I put the 5 here, and I think in terms of carrying a 4. And then the third step is 2 times 4 plus 4, which is of course 12. Now notice what we did. If we multiply these individually, as I pause the recording to finish without having you sit through all that I do, I find out that I actually made a mistake over here. This is what I get for not looking back at my notes, right? This is 47. So when I use 47, I should have had this number be a 7. and the rest of it goes on just fine. When I multiplied this out, I was going to show you how long division, how it all works the same, but notice basically it's this. I get this 9 by doing 6 times 4 is 24 plus the 5 is 29, right? In other words, this 29 and this 98 are the result of, hard to break it down into all the little parts like that. If you look at it, you can see the connections and how it all works together, but it is a separate way to solve it. And it's really hard to, all the numbers there are the same, they'd pull out the same, but it's hard to hard to demonstrate it. So these 3 steps are yet another method to multiply a 2 by 2 number, a 2-digit number by 2-digit number is the only thing this works for. You could do it that way. If it's easier, it requires a little bit of mental in the middle step. Certainly helps to be accurate, always with math, but that's a good one to do. Problem number 8, and this one kind of irritates me, just because on part C, they took 38 times 62. In order to get the answer they got, you had to round it to 40 times 60. Okay, that makes sense to me. But then you go on down to part E, and 238 times 54. In order to get their answer, you round to 240 times 50. Well, okay, we're not really rounding to the nearest 10. We're kind of rounding to the nearest, maybe the nearest tens, 24 tens times 5 tens. But then you go on down to part G, and they have 706 times 36, and they round this one to 700 times 40. I don't see any rhyme or reason about how you round these, so in my opinion, instead of making your child be too stressed out about getting it exactly like the book does, you just need to know that's pretty random. And so if your child rounds this one to 71 times 40, or 710 times 40, I think you'd have to count it correct. And if you round this one down to 200 times 50, that's a lot of rounding, so you don't really want to go too far, which is what concerns me about G. I don't know why they did it that way. So anyway, I'm making a list of things to ask them about, and that's one of them. But don't worry too much about it. The skill is estimation. If they can do estimation, they're in great shape. Number 9 and number 10 are very important, and they are important because they give you the basis for algebra in distributing numbers. Okay, and so the idea is this. Let me draw you a picture. If you're asked to solve the problem 52 times 12, now I just made this up because it's easier to draw than the one they gave me, but if I have 52 times 12, what we want to realize is that if I put a dot in each of these, and let's say that that dot is worth 2, does it make sense to you that this picture could be said is 50 12s plus 2 12s, or I should say 12 50s, same thing, right? 12 50s plus 12 2s. If the whole circle is 52, right, I have 12 circles of 52, where in each of them this is 2 and the white space is 50. So I have 12 50s and I have 12 2s. I can do that math pretty easy, right? The 12 50s, and again I said that my dot equals 2, 12 50s is 600, 12 2s is 24. So I just did 52 times 12 mentally, even got it right, and I did it the easy way because I can break that number down and do that simply in my head without having to do the whole thing at once. And number 9 is practice in getting all of those numbers or all of that done well. Now notice you can do it another way also. Over here on the left side of the page, I'll just call this method B. This is method A. I could say there are 10 52s and there are 2 52s because that math is relatively easy as well. It doesn't matter how you break it up as long as you end up with the right number, right? On the method A side, I left the 12s and I broke the 52 into a 50 part and a 2 part. For this problem, when I was doing 52 times 12, I left the 52 the same and I made the 12 into 10 and 2. Okay, 52 10s and 52 2s, or 12 50s and 12 2s. It all works out to be the same. In helping your child learn this skill, slow down on this page, make sure they learn it, and they can put it together. Number 10, also important, same idea, but just that I don't have to add them together. If it's easier, I could subtract them. So let me get that one drawn for you. Again, I revised the problem just so I could draw it a little easier. If I had the problem 19 times 15, so here I have circles. Each circle is worth 15, and I have 19 circles. There's a conspicuous non-existent circle here. But what I realize is I know 20 15s, that's equal to 300. So if I want 19 15s, I could count 20 15s, and then I could just get rid of 1 15, and that'd be easy to do because 300 minus 15 is 285. And that's a great way to do mental math with 19 15s. And in this case, it would not be as easy to turn around and do it the other way because it'd be a lot to get rid of. But this is 20 15s, subtract 1 15, right? And it is a good thing to see numbers that way because that's a distributive property. We use it a lot in math. It's a very good skill to know. Again, they're just helping us all through these sections to get better and better and better at multiplying and finding ways to do it mentally. Yes, there's a time to do it long-wise, but sometimes let's try it mentally. Number 12 has some more interesting things that we can do to make the mental math work. If I have 48 times 125, and we might say, well, that's all well and good. I don't count by 25s that well. But I count by 25s because I know all about quarters. So I could say that's the same thing as 48 times 5 times 25. Well, if I multiply this number first, and then I find out how many quarters, how much money that makes out of quarters, actually, and the answer just has us find that number. You know what? A great shortcut for 5s, 48 times 5 is going to be half of 48 times 10, right? 5 48ths is half of 10 48ths. So 480 divided by 2 is 240. So that's an easy way to find when you're multiplying by 5, because multiplying by 10 is easy, dividing by 2 is easy. That's a nice way to multiply by 5. Okay, so in that box is 240. Notice I took it to a 25, because that's an easier number to deal with. Let's look at maybe letter D, same problems. 150 times 207. The question says that's equal to 621 times how much? To find that, we have to realize that 207 needs to be multiplied times 3 to get to be 621. And so 150 is 50 times 3. So I didn't leave my box big enough. In that box goes the number 50. It's all about realizing that you can break things down and solve them that way. F is a similar kind of a problem. Look how that's worded. 35 times 13, we're told, is 455. So then when they say, what is 35 times 39? Well, I'm going to triple it, right? 13 times 3, so I have to multiply this one times 3. 3 400s is 1200. 3 50s is going to give me another 100, that's 1300. 3 50s is 150, and there's a 65 when I triple the 5. Again, whether they do that mentally or whether they have to write that down, it's going to eventually give them the same answer either way. Last thing actually to talk about today, number 13, notice on word problems, number 1, always use a bar graph. Okay, always draw a picture. And in this case, they drew the pictures for you, and that's good, but this models for you how to draw the picture. Again, I didn't work these word problems in the recording, just one under the section called word problems, but every one of those I drew a picture and showed what it was. Also, the second thing to always do is look for what am I being asked. So that sounds very obvious, but many times I've worked a problem and found all this information, and all I really needed to do was find a little part of it. So for example, number 13a, the question is, how much more did Charles collect than Bernard? And in the drawing, I think they left out the word more in the actual answer part, but Charles collected, it shows a picture there, 618 times how many. The more amount there is 4. And so just make sure, you could find out how much Bernard made, how much Ali made, how much Charles made, then you could find out how much more Charles made by subtracting, but there's no need. Once you know on part A, once you know how much a block is, and when you find it actually tells you that the block is 618, to know how much more Charles has, you just have to take 618 times 4. You don't have to find out how much Charles made and subtract. You just need to find out how much more Charles had. Okay, so all of those things are, the word problems are good. They are drawn out nicely, so use those bar graphs to solve it. And as much as possible, always draw a bar graph with your solution. So the word problems that are assigned this week are, of course, on a solutions recording, and so I don't need to go through those. You can find those anytime you want them. And I will see you again next week to talk over the 4th week of assignments.